All right. We're in section 3.5 where we're going to be solving inequalities using multiplication and division. Like I said in the lesson prior, this is very similar to solving equations using multiplication and division. The only difference is we're going to be using an inequality rather than an equal sign. So I guess the first thing I want to do is give a quick little review on what the inequalities mean. If you see an inequality that the carrot, or not the carrot, the alligator opens up towards the right side value, it is considered less than. If the alligator opens up to the right side value, it's going to be greater than. If I have a less than sign with a line underneath it, it's going to be less than or equal to. And the last one, if it's a greater sign with a line underneath it, it's going to be greater than or equal to. Okay. So, first thing we're going to talk about is the multiplication property of inequalities. One of the statements that I have over here, it says when multiplying an inequality by a negative number, you must reverse in order for the statement to remain true. So if you look at the first inequality that I have up here, I have 3 is less than 4. I know that this is a true statement. Okay? And if I were to multiply both sides by the same positive number, I would still get a true statement. So say I were to multiply both sides by 2. It would give me 6 is less than 8. It's still a true statement. But would it be a true statement if I multiplied it by a negative number? So say if I went 3 and I put 4 and I multiplied it by a negative 2 and I multiplied this side by a negative 2, I would get negative 6 and I would get negative 8. For this to be a true statement, I have to flip the inequality. So anytime you multiply by a negative number, not necessarily you're multiplying it to a negative number, but when you multiply by a negative number to both sides, you have to flip the inequality to make the statement true. I like to call that the weird rule. Okay? Now, you must be thinking, if it works for multiplication, does it work for division? Yes, it does. So when you're dividing by an inequality, same thing goes. If you're dividing by an inequality by a negative number, the signs must change in order for the statement to be true. So if like I were to divide both sides here by 4, which is a positive number, so I'd have 1 is less than 3, still a true statement. If I were to take 4 and divide it by a negative 4, and I would take 12 and divide it by a negative 4, I would get negative 1 and on the left-hand side, and I would get negative 3 on the right-hand side. The statement that makes this true is it has to be greater than. So the inequality must be flipped in order to make the statement true, because I divided it by a negative number. Again, this is part of the weird rule. So if I were to look at these inequalities, I have to solve them and then graph the solution. The goal is still the same. I want to get my variable on one side of the inequality by itself. So in order to do that, for this first example, I have to multiply both sides by 6. This will cancel out here. which then leaves me with n, and I multiplied it by a positive number, so it's still left is greater than, and 7 times 6 is 42. If I'm going to graph this, I have this to be an open circle because there's no line underneath it, and my arrow is pointing towards the right. Okay? Looking at 2x is greater than negative 8, in order to get x by itself, I must divide both sides by 2, which cancels out here, which leaves me with x, and I divide it by a positive 2, so the inequality stays this on the same side, and it is a negative 4. Now, if I were to graph this inequality, negative 4 here, it is a open circle, and it is a opening towards, the shading goes to the right. Looking on the bottom, I have t divided by negative 4 is less than or equal to 8. So in order to get t by itself, I must multiply it by negative 4. So this cancels here. I have t by itself. Now, I multiplied by a negative 4. Now the weird rule has to be implemented, so now I have to flip the inequality, which was less than or equal to, is now greater than or equal to. And 8 times negative 4 is a negative 32. If I were to graph this, put negative 32 on in the center, it is going to be a closed circle. And again, it's going to be opening to the right because my arrow is pointing to the right because my variable is positioned on the left-hand side of my inequality. The last one here in this page is negative 7s is less than or equal to 14. I must divide both sides by negative 7 to get my s by itself on one side of the equal sign. So this cancels, and I divided by a negative 6. Again, the weird rule has to be implemented because I divided by that negative 7. And 14 divided by negative 7 is a negative 2. So when I graph this, got negative 2. It's going to be a open circle, and it's shaded to the right. Okay. Last thing here is I have some verbal statements, and I'm going to write those out as inequality expressions. So it says a number, which is x, which is divided by 4, is at most 8. So is at most. So could it be more than 8? No, it cannot, because it's at most is 8. So the largest value it could be is 8. So that means my alligator has to open up towards the 8. Could it be 8? It is at most 8. I would say that it could be equal to. So for this statement here, it's x is divided by 4 is less than or equal to 8. Here I have 3 times a number is more than negative 18. So I have 3 times a number, and then I have it more than 18. So whatever 3 times is going to be more than 18. So my alligator opens up towards the 3x. Can it be negative 18? It says it's more than. It's not more than or equal to. So there's no line that goes underneath my inequality symbol. So it's 3x is greater than negative 18. And that is being able to solve inequalities using multiplication or division. Hope this helps. Till next time.